All right, today's notes we are going to be talking about solubility curves, also called solubility graphs. And so we have some nice graphs here that, if you look at all of them, have the same things in common, where the x-axis is always going to be temperature, and the y-axis is always going to have the solute mass. And if you look at them, they're also going to have how much solvent is present, and here it's per 100 grams of water, but it might be per 200 grams of water, it might be per 1,000 grams of water, it might be per 100 milliliters of water. So that could be different, but it will always be the grams of solute. And then the third thing is that some question will be asked of you to interpret the solubility curve. They might ask you to find the temperature, they might ask you to find the mass, and they also might ask you to describe the saturation. So finding the temperature means you're going to know the y-axis and you're going to have to look on the x-axis. If they ask you to find the mass, that means you know the x-axis and you want to find the y-axis. If they ask you to describe the saturation, that is asking you to look at where the value that they give you falls in relationship to the curve. So we'll practice that here in a minute. So reading the solubility curves. So first of all, just observing the pattern. So let's look at these questions. Which substances are more soluble as temperature increases? So as we look at the curve, which substances are more soluble as temperature increases? So as we look across the x-axis, as temperature increases, we look at our lines, and most of them are going up. Even one's right, where's it at? Slightly up. Here's one up here. So most of them are going up. So right here it says if the slope is positive, the line curves up. That means as temperature increases, more solute or mass dissolves, aka it's more soluble. I'm reading this part right here. So who are those? Well, I'm starting at the top here. Potassium iodide, then sodium nitrate, then potassium nitrate, then ammonium chloride, then potassium chloride, then sodium chloride, then potassium chlorate. I think that's it. 6, 7, 1, 2, 3, 4, 5, 6. Yep. Then it says which are less soluble. So let me switch colors. If they're less soluble, that means they're going down. Well, I see one going down here and one going down here. That would be NH3, which is a nitrogen trihydride, but its common name is ammonia. And the other one is cerium sulfate. Ammonia is a gas, so that makes sense that as you heat up a gas, it's going to be less soluble in water. And then some solids are actually less soluble, some solids. All right, the next question is interpreting our x and y variables. It says what y variable corresponds to a specific x. So this is just reading a graph. Where do they intersect? Sample question 1, and I know we have the answers here, but I just wanted to practice with you. It says what mass at 60 degrees Celsius, and it's for sodium nitrate. So we're going to find sodium nitrate, which is right here, and we're looking where it intersects at 60 degrees. So we kind of go up here, 60 degrees, and it intersects right here. So we go across, and I know I don't do a very good job, but it intersects right at, right there, which is 125 grams. That means at a 60 degrees Celsius, you would get 125 grams of sodium nitrate to dissolve in 100 grams of water. So if you had 100 grams of water, which would actually be 100 milliliters of water, because water's density is 1 gram for every 1 milliliter, you could dump in 125 grams of sodium nitrate and you would get it to dissolve. Sample question 2, what temperature is required to dissolve 59 grams of ammonium chloride? So now let me erase this and use a different color maybe. We have ammonium chloride, so now that's this color. I'll use red. And we're looking at 59 grams. 59 grams is just shy, 59 grams, excuse me, this one. Just shy of 60 grams. So we go over here, and it intersects about right there. And we go down, we're about, oh, I guess I didn't do a good job drawing my line here. It's 59 grams. It's kind of hard with my thing here. 59 grams, so it's about right there. So when you go down, that's about 70 degrees. The stylus, I'm not very good at that. Sorry about that. All right. Let's go ahead and move to the next solubility curve, calculating solubility. Here you're just using proportions. So not every sample that we want to make is going to be 100 grams, like the graph is set up for. So in this case, they want to know when we're making a saturated solution, how much can we get to dissolve in 150 grams? Well, remember, this is set up for 100 grams. So at 15 degrees Celsius, so here's 15 degrees Celsius for Ki, we can get about 141 grams. So that's where they get this. We can get 141 grams in 100 grams. But they want to know how much we can get in 150 grams of water. So they set up this proportion. And so to solve it, you cross multiply 141 times 150, multiply these two, and then divide by 100. And you get about 211.5. I know that sig figs aren't necessarily covered right here. It would actually be about 210 grams with sig figs because the 150 only has, right here, only has 2 sig figs. This has 3. The 100, I would assume, has 3 sig figs there, but we'll see. Not worried about sig figs right here because it's somebody else's work and I can't really assume. All right. Next one, reading a solubility curve. How much more solute can dissolve? So in this one, we're looking at a graph, seeing how much can dissolve, and then seeing how much extra might be able to dissolve. So they're saying how much more KClO3 can be added to a solution that contains 20 grams dissolved at 75. So at 75 degrees Celsius, here's 75, they're saying 20 grams are dissolved at 75 degrees Celsius. So 20 grams dissolved is right here, 20 grams. And you know, here's the line. So this point of saturation is, you know, about 36 grams could be dissolved. That's how much would make it saturated. But we're right here, so we are unsaturated. And we know that only 20 grams have been dissolved. So the difference between those is 16 grams. So you know you could get 16 more grams to dissolve. This would be kind of like if you were making Kool-Aid and the recipe called for 2 cups of sugar, and you only had a cup and a half of sugar in your cupboard. You know that you could get an extra half a cup of sugar to dissolve in there because the recipe called for 2 cups, but you only had a cup and a half. So you know you made an unsaturated solution. So when you're comparing let's say we had our sodium nitrate. Here's my sodium nitrate line. If I'm below the line, I'm unsaturated. If I'm above the line, I'm supersaturated. And if I'm on the line, you'd call it saturated. Alrighty. So again, you have no assignment to go with this yet. You're going to just do your Nearpod.